All right, so here are our 6 carbon structures. These are all of our D-aldoses. Now, what I want to do is work through these different sugars just like we did our 5 carbon sugars. And the first thing that I'm going to do is I really want to simplify this down as much as possible. And I want to show you that this kind of wall of information really isn't that much that you have to worry about. So we've got a total of 1, 2, 3, 4, 5, 6. And if you look at all of these different molecules, they have unique names. Okay, 5 and 6. Now what I want to do is I want to go ahead and eliminate the sugars or the carbons that we don't need to worry about. Carbon's 1. They're all aldoses. They're all going to have the exact same structure right there. Okay, next up, carbon number 6. They're all going to look the exact same at the carbon number 6 position. The last thing that we need to worry about is, well, they're all D sugars. Therefore, at carbon number 5, our penultimate carbon, they're all going to have a hydroxide group on the right-hand side. So I want you to think about this as if I were going to be drawing this, well, you've got 50% of the structure ready to go. Okay, then what you need to do is really just kind of find out some information to hang your hat on. So there are tons of mnemonics that you can look up online, and they're all, you know, they're clever and everything like that. But what I would recommend that you do is, and like I said, you're not going to have to draw these. What I want you to be familiar with is the relationships between sugars. For instance, I will give you the structure of glucose. Like I could give you all of these molecules. I could give you a structure that shows all of these molecules and ask you, identify which sugars are C2 epimers of one of them or something like that. And, you know, kind of like which sugars are C2 epimers of one another, which are C3 epimers, which are C4 epimers of one another. So I hope that makes sense. And I'll show you some examples before your actual exam and stuff. But what I would recommend doing is I would be familiar with the names of several of them. The ones that I think are the most high value are the ones that are boxed here. Because these are going to be the ones that are most relevant to courses that you take in the future. And they're the most biologically relevant. So glucose, if you know the structure of glucose, that's going to help you out a huge amount. And so what I do for this is I just use a simple code for myself of RLR, right, left, right. So I use that because I only need to worry about 3 carbons for the structure of glucose. It has 6 carbons, I know that, but I don't need to worry about carbon number 1, carbon number 5, or carbon number 6. I only need to worry about carbons 2, 3, and 4. And those have my hydroxide groups on the right, the left, and the right. And I'm starting from the top and going to the bottom. So I've got RLR. I've got that in the back of my mind, so then I can just say, okay, well, if I see anything like that, for instance, the sugar right next to it, D-mannose. Does mannose have a relationship or structural relationship with D-glucose? Well, what does mannose have? This would be LLR. My hydroxide group's on the left, left, right. So this would be a C2 epimer. Okay, now let's go a step back. Glucose and maltose. What's different about glucose and maltose? Are they epimers of one another? C2, those are different. Okay, so there's a possibility that they're C2 epimers. C3, oh, those are different. So what I would do with this is I would say they are not epimers because of the fact there is a C2 and a C3 difference. Okay, now if I compare, and I'm going to switch colors here, if I compare allose and glucose, what makes allose and glucose similar, but what makes them different from one another? Okay, C2, glucose and allose, identical. C3, I'm going to highlight this, or I'm going to circle this, those are different. So there's a possibility that glucose and allose are C3 epimers. C4, identical. So that's my relationship between glucose and allose. They are C3 epimers of one another. Okay, now the next one that I want to look at would be, well, can I find a C4 epimer of glucose? Yes, I can. And what am I looking for? Well, I'm looking for something that is R, right? A hydroxide group on the right-hand side for carbon 2. Hydroxide group on the left-hand side for carbon 3. And hydroxide group on the left-hand side for carbon number 4. Well, what do I have? So I'm looking for RLL. Well, does gulose fit that billing? It doesn't. So that's out. Galactose, on the other hand, it's got right, left, left. Perfect. That is my C4 epimer of glucose. Okay, now I'm not going to go through every single example here, but I want you to be able to recognize, and I would recommend using the same sort of system, this RLL or something that makes it simpler for yourself. This is the sort of thing that would be a good test question. What's the relationship between these sugars? Identify which are C4 epimers, which are C3 epimers. So I'm going to go ahead and this is going to be the end. This is a video that's only one slide long, but I want you to spend some time seeing and practicing those relationships. And so what I would recommend is get a piece of paper out, draw these structures, and maybe make a photocopy of it or something like that, and just try drawing, well, what's the variation about this carbon? What's the variation about this carbon? With these 6 carbon structures, we are only focused on 3 of those 6 carbons because the other 3, they are already committed to give us that D-hexose structure. Sorry, D-aldohexose. These are all D-aldohexoses. Okay, so I'm going to stop.